today's lesson is called optimization. Optimization is a word problem for absolute extrema. So the goal is to minimize and maximize certain variable that you want to find. The process of solving optimization could be broken down to three simple steps. First, identify what you want to maximize and minimize. Two, identify if there is any constraint, also known as conditions. Third, find the extrema using the first derivative test. So let's take a look how to solve optimization problem. Example 1. Peter wants to construct two identical rectangular corrals using 200 feet of fencing. Peter decides to build them adjacent to each other so they share fencing on one side. What dimension should Peter use to construct each corral so that together they will enclose the largest possible area? So the first thing I'm going to do is I'm going to try to sketch this so I could have an idea of what they're trying to solve. So it seems like they're going to try to create a fence and they're trying to make it two identical things. So we have two identical rectangular shape. And what we have is 200 feet of fencing. I'm going to try to label some of these sides. I'm going to call this X. I'm going to call this X. And the vertical side, I'm going to call it Y. The goal to this problem is they want to try to maximize the area as possible. They say they want to make the largest possible area. So our goal is to maximize the area. So the step one we said was to identify what you want to maximize. We want to maximize the area. So our area equation for this problem will be our main goal, which is in this case 2x times y. Now, is there any condition? We're limited to 200 fencings. So only thing we could use is 200. So if you add up all the fence that you're going to try to build, it has to add up to 200. So we have 2x plus another 2x plus 3y is equal to 200 fence. So in other words, we have 4x plus 3y is equal to 200. Keep in mind, area is what we want to maximize, so we're going to try to substitute our condition, which is keeping at a 200 feet of fence, into the area formula to form a one single equation. I'm going to solve for x. So we could say x is equal to 200 minus 3y over 4. So our area equation will be 2 times 200 minus 3y over 4 times y. Now let's clean this up a little bit by multiplying. So we have 2 divided by 4, which is 1/2. So we have 100y minus 3 over 2 y squared. So now we have an area formula with our condition added in. And then if you guys remember, the third step was use the first derivative test to solve the extrema. Our goal is to find largest, which happens at maximum and minimum. That's what we're looking for first derivative test. So I'm going to find the first derivative, which is 100 minus 3y. So we can see that critical values in our case will be 100 is equal to 3y, and y is equal to 100 over 3. Now let's think about any restriction in terms of domain. Because again, our goal is to figure out the largest possible, which means it has to be an absolute extrema. Since we're dealing with fencing, we're dealing with length. Therefore, our y value, which is the length of a fence, has to be greater than 0. So when we test our first derivative test, we're going to start from 0. I'm going to choose 1, and I'm going to choose, this is about 33, so I'm going to choose 100. If you substitute 1 into the derivative, you'll find that it comes out to be positive. And if you substitute 100, then you're going to come out with negative. So at y equal to 100 over 3, you'll find that it will come out to be as maximum. So at y equal to 100 over 3 is your maximum. Let's go back and solve for the x, because our goal is to figure out the dimension. So x is equal to 200 minus 3 times the y. Which in this case it will be 100 over 4, which is 25. So basically at x equal to 25 feet, and when y is equal to 100 over 3, we have maximum area. Now just answer the question, because our goal is to figure out the dimension of the corral. Our corral is supposed to be 50 feet by 100 over 3 feet. And this will produce the largest area while maintaining 200 feet of fence. Okay, let's look at one more. Example 2. We have 45 meters square of materials to build a box with a square base and no top. Determine the dimensions of the box that will maximize the enclosed volume. So once again, we have a box in this case. Just keep in mind open top. So in other words, there is no top. They want to maximize the volume. So volume is our extrema. While label, I'm just going to label as y and x and x. Just keep in mind they did say it was square base, so the length has to be equal. So we could say the volume is equal to x squared times y. Now, is there any constraint? We're limited of 45 meters square of materials. Again, meter square is in the areas. So we have 45 meters square of the materials, which indicating that surface area of the entire box has to add up to 45. So sometimes looking at the units will help us to determine what we have as our condition. So our surface area in this case, so we have a bottom piece which happen to be x squared, and we have two sides and front and back which happen to be the same length because we have a square bottom. So we have 4 times x times y as our 45 meters square. Again, we don't have to worry about the top because the top is open. It says no top. In this case, we have x squared and x, so it's easier to solve it as y. So we have y is equal to 45 minus x squared over 4x. Now we know the condition. We're going to substitute it into the volume equation because that's what we want to find. So x squared is equal to so the volume will come out to be x squared times 45 minus x squared over 4x. Now if you simplify this, you get 45 x squared minus x to the 4th over 4x, which is same thing as 45 over 4 times x minus 1/4 of x to the 3rd. Now take the derivative, 45 over 4 minus 3 over 4 x squared. Find the critical value. Which happened to be radical 15 as our x. So just like before, our domain for the x, because of the length, it has to be greater than 0. I know the radical 15 is little less than 4, so I'm going to choose 10 to be safe. Again, pick any number. If you're in doubt, just pick a really big number. I'm going to choose 1 to test out a first derivative test. If you substitute 1 in there, you'll end up with positive. If you substitute 10 in there, you're going to end up with negative. Once again, at x equal to radical 15, we have our maximum. Now when you go back and substitute x into the y, we get 45 minus 15 over 4 radical 15, which comes out to be 30 over 4, which is 15 over 2 radical 15. So the dimension has to be x has to equal to radical 15 meters, and y has to equal to 15 over 2 radical 15 meters in order to maximize the value.